Solutions to problem 173. Oops. Yeah, I misspoke. I said today, June 21, is the beginning of the fall on the southern hemisphere. That, of course, is not true. It is the beginning of the winter on the southern hemisphere and the beginning of the summer on the northern hemisphere. Yeah, slips of the tongue happen. That's the way it goes. It's part of life. Hello, hello, hello. Today is Wednesday, June 21, 2023. A special day, June 21. The summer solstice. Yeah. So on the northern hemisphere, it's the longest day, the shortest night. Southern hemisphere, it's reversed. That's why we call it the summer solstice, because we live on the northern hemisphere. All right, so here on the northern hemisphere the summer starts, and on the southern hemisphere the fall starts. Our summer will end on September 21. All right, so much for astronomy. A solution problem 173, the slingshot problem. I decided to use Ulf Heller's solution. I could have chosen M. Droygen's solution. I could have chosen Carlson's solutions. I just decided to choose Ulf Heller. If we assume that this slingshot is like an elastic collision, then both kinetic energy and momentum are conserved. That is key. Once you have that idea, the whole problem is going to be a piece of cake. Let V prime, lowercase v prime, and capital case V prime be the velocities of the spacecraft and the planet, respectively, after the collision. So before the collision they are lowercase v, capital V. After the collision they are V prime, lowercase, and capital V prime. So the conservation of momentum then follows immediately. I'm not going to massage you through all these equations, but this is what Ulf Heller has. So you can massage your own thinking through this. And so this then is the result of the conservation of momentum. And then here you have the conservation of kinetic energy. I will not massage you through that either. And if you now combine this last result with equation 1, then we get this. This was equation 1 here. The result of the conservation of momentum. And so then you get the final result. Very nice result, isn't it? V prime, lowercase, is V lowercase plus V capital plus V prime capital. And so that's the answer to A. Since capital M is way larger than smaller m, than lowercase m, V prime is approximately the same as V. And so V prime is then V approximately lowercase v plus 2v. Go upwards again, and then you can convince yourself that this is correct. If capital M is way larger than lowercase m, V prime is about V. And of course, you don't even have to go upstairs, because that's completely intuitive, right? the speed of Jupiter could really not change by any noticeable amount. Because think of the mass of Jupiter. So clearly, capital V prime must be the same as capital V. So we are being given that the velocity of the spacecraft was 10 kilometers per second, and the velocity of Jupiter was 13 kilometers per second. So out pops the interesting result that V prime has now increased from 10 kilometers per second to 36 kilometers per second. Yet the speed of Jupiter has practically not changed at all, but of course it has to change by a minute fraction. That fraction is so minute that you can ignore it. So the kinetic energy before the spacecraft was 1/2 m lowercase v square, and after the collision 1/2 m lowercase v prime square. And now you see something quite amazing. The kinetic energy increased from 10 to the 11 joules to 1.3 times 10 to the 12 joules. So it went up by more than a factor of 10. And that's the secret behind slingshots. And NASA uses it all the time when it sends spacecrafts to other planets. They always use planets to slingshot it and thereby increase its kinetic energy. Is this a high school problem? Yeah, I would think so. Maybe not for all of you, but yeah, probably for me it was. If it was not for you, don't feel bad. It's very interesting though. The physics is really beautiful. And it has some practical, serious consequences. It's being used almost all the time. All right then, take care. And of course, the most important conservation of physics is always, and that will never change, that we will be friends.